And welcome YouTube to our daily space weather video. It's the main feature over here at the Smash News Network, least busted name of news. We've been doing it over 5 years. And what we're looking at here is the sun. That's from the Gov 16 SUVI. That's the last about 2 hours. And we did download one video from Helio Viewer here. This is the Proba 2 swap instrument, 174 angstroms. That's the last 24 hours. We've seen a drop in solar activity in the past day, and we decided to put everything in one convenient video for you here right on YouTube. Some great imagery there from the swap of the Proba 2 mission. Radio flux has come all the way down to 115 solar flux units. There is the 1-year chart. It's the black line to show the radio flux. And for you new viewers, the 10.7 centimeter radio flux is the most proportional data that we have to the sunspot number. You can see this red line below it, perhaps, and see the way that correlates with peaks and troughs in the radio flux. Sunspot number, red line, radio flux, black line. Space Weather Enthusiast dashboard, calling for a little bit of geomagnetic unrest late tonight and some geomagnetic unrest early tomorrow on June 26th. So there's that. We have seen a big uptick in the solar field intensity here. The BT now at 13 nanotesla, and it has moved into negative territory since we did show prep as well. So I think there is a coronal hole wind stream headed this way, and that is what NOAA is forecasting as well. It's that's the coronal hole high-speed stream is what NOAA is forecasting this geomagnetic unrest period for. Next, we'll look at global seismicity, and we're not suggesting that the sun causes or forecasts earthquakes. However, we are suggesting that the likelihood of major earthquakes is statistically quite high here. We've been having an earthquake drought. Only 2 7-magnitude earthquakes showing up there on the 90-day bar graph. If you're in an earthquake-prone zone, please have a plan to be an asset, not a liability in the event of a disaster. Know which buildings may go out. Know what will happen if your power goes out for an extended period of time. We're seeing an earthquake lull for the past 90 days, really, and earthquake droughts and in large earthquakes. So no major quakes here over the past 24 hours. There was a 5.1 in Indonesia. That was one of the largest quakes. And I'm just scrolling up the list here so all of you can see where and when. There was a 5.6 in Iran. That was the largest quake of the past 24. And there was also a 5.1 in Chile. So only 3 quakes there in the 5 magnitude range. Again, that's an earthquake drought. We're also seeing a downtick in volcanic activity. Shout out to Mary Wright. So the volcanoes that are still erupting appear to be Chikarachi. Although volcanic ash not identifiable in satellite imagery, don't assume it's not erupting and decide to pole vault the caldera. Semeru on East Java, Indonesia, exploding, flight level 130 from Semeru. Fuego exploding in Guatemala, flight level 150. It's a 15,000-foot ash plume over the Central American nation. And Sabancaya exploding, flight level 210 over Sabancaya. Again, don't pole vault the caldera. Let's get back to the sun. So here's the NASA GOES 16 SUVI 94 angstroms view. And if any large flaring does happen, we can expect to see it on these wavelengths. 94 is a great view to watch flares. You'll see a brightening right here just recently. A little bit of minor flaring happening there as we record the video. That's the last 2 hours from the GOES 16 SUVI. And let's take a look at the earthly geospace here. There's our geospace magnetosphere movie. Let me bring that back as I was resizing. We've got a pretty homogeneous magnetohydrodynamic pressure here surrounding the planet. That's the Earth out to about 12 Earth diameters. That's about the size of Earth's magnetic moment from space. Earth, it's a giant magnet. You live on it. And this is how it's interacting with the solar wind and the outer environment there. That's magnetohydrodynamic pressure. Next, looking at ground magnetic perturbations here. Geospace delta B, changes to Earth's B field at the surface level. This scale is modeled in nanotesla magnetic flux density. And those red spots are the most likely places to see induction into power lines, to see aurorae, and also induction into pipelines and railways. KP index at 2. Again, NOAA expecting the KP to be at 4 late tonight and early tomorrow from a coronal hole high-speed stream. It all depends on how the fields play out. And again, we just saw the fields shifting here. As we did show prep, you can see the fields got stronger. And the vertical component now still shifting around here. If we do see a strong negative BZ signal, which is this red line, we can expect to see maybe even a geomagnetic storm condition. Current conditions are, for the solar wind density, about 4 protons per cubic centimeter. Solar wind speed, about 410 kilometers per second. There should be a good signal when we see an incoming coronal hole high-speed stream. What we expect to see is a big increase in the solar wind density, and then as that drops off, a big increase in the solar wind speed. Next, go into magnetic data, and we're seeing some lower readings here on the GOES magnetometers. If you're new to the channel and you're wondering what those arc jet moments are, those are when the GOES, let's see, that was the GOES 16 turning on its thrusters. Those thrusters create plasma, which can affect the magnetometer readings. Here's some more magnetic data for you from the Gong 2. This is the polarity of the heliospheric current sheet. And we may have a North Pole current sheet snapping through here in the next day or two. It all depends on what type of activity we have in the earthly facing portion of the solar disk. We'll keep an eye on it. Here's our line of sight plot. It shows the solar magnetogram, the solar B field in blue, that's the blue lines there. North solar polar field in green, south solar polar field in red. Continuing on to coronal holes. Again, we are expecting a high-speed wind stream from some coronal holes. We've got only south pole-oriented coronal holes right now in the earthly facing zone. They're not super well defined. They're shown there in red. And here's some imagery in 195 angstroms from the GOES 16 SUVI. And no major super well-defined coronal holes at the moment, just sort of peppered with coronal holes. That's the last 2 hours from the GOES 16. And let's move to sunspots. We've got some filaments in the earthly facing zone as well. And there's some imagery in 195 angstroms from the SOHO on the right. Here's our GOES 16 thematic map. And the most likely place to see major flares would be, well, you could still see some from this area. And we have seen some flaring increase in this area as well. Next, looking at the magnetogram from the El Teide, Spain ground-based solar observatory. This is Sunspot 3040, I believe is the name of this one. It has actually lost a little bit of magnetic complexity over the past 24 hours. Next, the up-to-date intensitygram imagery from El Teide, Spain. And you see this leading umbra in front of Sunspot 3040's main umbra. It has mostly degraded over the past 24. So it is a downtick in solar activity. Also the X-ray flux down. We'll get to that next. So there's the GOES X-ray flux over the past 3 days. If you look at it over the past 7 days, certainly declining there a bit. Bit of a downward trend there. And a reduction in sunspot number and the radial flux, as we covered earlier. So the proton flux showing flatlined readings here. No relativistic particles. No major flaring. And here's the last 2 hours in 131 angstroms. Gotta love that GOES 16 SUVI when the SDO data is down because of a power outage at Stanford. So we regularly do stream live to Twitch. Today we put all of our videos as a YouTube exclusive. Make sure you follow us on Twitch if you want to see when we go live. We regularly put up breaking news on the Twitch channel. When something goes on in space, we're usually on it. If you're sick of not seeing our videos in your subscription feed, make sure you head to smashomash.com/smashteam and click posts. We put all of our major releases in there. And also, if you're signed up at the gold or silver Smash Team level, you will see all of the special posts that you're able to see that are unlocked by your login. So thanks to our gold and silver Smash Team level, you can find links to everything at the homepage at smashomash.com. There's also Patreon. We're on Facebook. We're all over social media. Check us out. Welcome to the Neo Renaissance. We're glad to have you. Congratulations on realizing the channel exists. It has not been easy getting you people to watch the content. So press like and subscribe. Tell your friends and foes about us. Once again, thanks for tuning in. We appreciate your patronage. And we're trying to make America not suck again. So it's part of our mission here. If you notice, I'm wearing the Mensa hat right now. That stands for Make Earth Not Suck Again. And part of the reasoning for making Earth not suck again is making America not suck again, as the U.S. leads the way in so many ways. You know, some of the good news about the inflation going on in the U.S., folks, is that the U.S. dollar is still the strongest currency. If you don't like fiat currency, well, nobody likes fiat currency who understands anything about economics. However, the U.S. is still the best place to invest because other fiat currencies are experiencing even worse inflation. So, this is not a political slogan in any way. Make America Not Suck Again is completely apolitical, just like I am. I've never belonged to a political party, probably never will. So, in an effort to make Earth not suck again, we implore you to make America not suck again. Engage. Press like, press subscribe, leave a comment. Press that share button and share on your social media if you're a larger channel. Hit us up. We'll gladly bring you on the channel for an interview or appear on yours. Thanks everybody who's helped us out over the last 5+ years of our Making Space Weather videos. Let's get back to the data. Here's what's going on above my head in Lehigh Valley. This is a star chart from in-the-sky.org. And these mornings for the past month or so have been a series of great mornings to get up and look at the pre-sunrise sky. And at the moment we've got Saturn, Jupiter, Mars, the Moon, Venus, and Mercury all rising ahead of the closest star. That yellow line is the ecliptic. The blue line here is the galactic plane. Here's a solar system forecast for you. Keep in mind this is not to scale. And also remember, since this video is on YouTube, the planets are not going to kill you. Here's your forecast for the solar system. Let's forecast this 1 week. As we approach a new moon in 1 week, we will have a crescent waxing. That's where things will be on July 7th. So we failed to show some coronagraphs yesterday because there were broken links. So we're going to show this detailed coronagraph with computer analysis on the left and the raw Soho-Lasco C2 data on the right. That would be yesterday. And here is today's data. And we'll also show some additional data here, including the stereo A coronagraph. So stereo A is located here at Lagrange 5. We'll also show the Soho-Lasco C3 located here at Lagrange 1. So there are some filaments. We may see coronal mass ejections at the moment, the last day or two. Nothing to report on. And we'll let that play through just to show you the data. A lot of facts expressed on our channel. Maybe that's why we've only got 2,500 subscribers, as our subscribers have been stagnated despite all kinds of different changes being made. That's the last coronagraph data. And we've got even more information for you here. Here's the NASA GOES 16 SUVI, 284 angstroms. Some fantastic imagery there from the past 2 hours. And let's continue on into our bonus features segment. So now we're looking at the total electron content forecast. These are the most likely places for GPS errors. And we actually saw some satellite errors happening on our windy.com map that we're going to show you, as this space weather video will include bonus segments including meteorology data as well. So we're not talking about nonsense about what the sun does and doesn't do. We're just citing facts, and we do see some anomalous zones of electron flux down here. Some minor additional Van Allen belts essentially forming down there by Antarctica. You can see that area down there around the Southern Ocean and the Antarctican continent happening. So some more anomalous spots for GPS errors happening, and some pretty irregularly shaped electron regions here. So the total electron content forecast is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And in between that satellite is a plasmasphere, a Van Allen belt, sometimes another plasmasphere, and the ionosphere. And that can cause huge refraction of your GPS signal. That's how the errors work essentially in a nutshell. And again, we do see some charging hazards here. So we actually saw some evidence of this on the windy.com satellite imagery. We'll see if we can show you that in a minute. There are some surface charging hazards happening around the western Mexico, moving into the central Pacific Ocean, and so on. Continuing on, here's the GOES electron flux over the past 7 days, and we made it into warning territory for the past week each day. We normally show the 3-day chart. I just wanted to show the way we've been in a sort of a nominal range here. Electron flux, not super high levels. Here's the forecast model. And I would say we're going to see a big dip in this actually, because we are expecting a coronal hole high-speed stream. That's the forecast from NOAA, the green boxes. Here's the 1-year chart to put it in context. And we're at relatively high levels here of electron flux. Nothing to write home about. We'll also show the ionosphere. So here is the F flares intensity, the F flares ionogram, and anomalygram. We'll show you both of those in animated glory. So this is the previous day of the Ionogram, courtesy of Australian Government Bureau of Meteorology. And here is the anomaly. This is anomaly in megahertz from a 30-day median. I'll call it the anomalygram. So some low-frequency anomalies happening there, especially around the southern hemisphere. Keep in mind, it is winter south of the equator. And let's bring up the latest image here. Here's the latest image on the Ionogram. That's 10:15 Universal Time. There's 10:15 Universal Time on the anomalygram. And continuing forward, let's take a look at the latest from El Teide, Spain. So here's the latest intensity gram from El Teide, Spain. Keep in mind the data is about 25 minutes old when we recorded the video. Zoom that out to show you all the information. Again, Sunspot 3040 has degraded a bit, as you can see in the latest imagery. There's the latest image. Although there are still some additional umbrae around it. So we did see some flaring looking like it was happening earlier in the video. And don't be surprised to see a major flare from this area as it approaches the limb. It is certainly quite magnetically complex and capable of producing large flares. Again, the SDO data is down because the host of the SDO data, Stanford University, is experiencing a power outage, an extended one. So no additional data there. We will close out our space weather content for the day on 304 angstroms. You can see some of the filaments up here, some significant filaments, especially around the northern hemisphere, some in the south as well. And 304 angstroms is great to view coronal mass ejections when they happen, especially on the GOES 16 SUVI, because it has a lower resolution but a wider field of view than the SDO. A benefit of viewing the NASA GOES 16. So now we're going to break into the realm of meteorology here at the Smash News Network for a brief moment. So let's blast through some meteorology information, and we're going to start out by looking at some dust. Many of you may be aware of the fact that dust blows across the Atlantic Ocean from the Saharan Desert, and there you can see a great example of that as we look at the DUX. Aerosol optical thickness at 550 nanometers, so it's dust, and it's fertilizing South America right now. It's an interesting feature of what goes on planet Earth. Now we're going to switch back to our normally scheduled meteorological data. Here is your jet stream scenario for the eastern world. So those are the jets of the east. It's the 250 hectopascal winds. Here are the surface winds of this side of the planet. And here are the surface winds of the Americas. And we do have this strong system here off the coast of Mexico, still hanging out there. And here is the jet stream scenario. Looks like some cooler air driving into the southeastern U.S. there, and most of the jet stream activity once again staying north of the United States. Here are the jet streams of Europe and Africa. Doubled up jet streams in both hemispheres there. And we do have an upper level anticyclone right here. You can see this clockwise rotation. The signature of northern hemisphere anticyclones. Here are the surface winds of this side of the planet. And let's blast through some more information here. We don't want the video to be too long. Thanks to everybody who's tuned into this point. And here's our weather.gov map. We've got some, what do we have there? Some red flag warnings there in Alaska, it looks like. If your county is lit up on the map, just head to weather.gov and click your county. Some heat warnings there in the south central U.S. there around the Mississippi Valley. Continuing on to our GOES lightning mapper. There's been some heavy lightning in Florida. Check it out. Hardcore lightning there over most of the state. Yowzers. And Florida is the lightning capital of the U.S. Lots of convection happening there with the Gulf of Mexico on one side and the Atlantic Ocean on the other. Florida, it's surrounded by hot water. All right, and here's the current real-time lightning map from lightningmaps.org. And we do have a quite active cell here. Anyway, there's the location of that. We don't want to spend too much time on it as we got to get this video uploaded. So let's show a forecast. Here's your 72-hour GFS pressure and precipitation forecast. And we're expecting a series of strong storms here across the southern U.S. You can see all those little areas of red. They'll be in concentrated areas, but they will be strong little storms, it looks like. However, in the north-central U.S., we're expecting a little bit more activity there. So we've brought up a 72-hour GFS forecast for that area as well. Going to be some extreme weather there over North Dakota and northern Minnesota. So here's our windy.com map, and we've got a great example here of signal refraction. You're going to see a distortion on the map right there. It's a great example of free electrons messing with a signal. So you're going to see like a distortion happening there right at the beginning, and then that box forming. That's because the satellite knows that it's getting some bad data, so it blocks it out. Great example there of the distortion that you get from free electrons affecting signal integrity. Windy.com has a great mobile app, by the way. Maybe check that out if you like. We are not paid to tell you. That's another public service message from the Smash News Network, least busted name in news. So now we're going to focus on the lower 48 primarily for the rest of the video. Here's the all 50 state view. And we'll zoom in on our animated radar map. That's radar.weather.gov if you're wondering. And you can see those strong storms headed for Lake Michigan. Milwaukee, Chicago, Detroit, and Cleveland. You're all likely to see some weather today. Here's our shortwave radiation map showing clouds and fog. And some rapid cloud nucleation happening here over eastern Iowa. Check it out right here. You can see clouds suddenly forming there as moist ground suddenly leads to moist skies. Here's your recap. The U.S. Doppler radar map from radar.weather.gov. Here's our shortwave radiation map at 3.9 nanometers, part of the NASA GOES Interactive Weather Satellite Suite. And here's the water vapor. If your Doppler radar is not giving you the full picture, this may help. So check that out the next time your Doppler is not panning out for you. The water vapor map should tell you what's going to happen next. And next, we got to end this video, so thanks for tuning into the Smash News Network Least Busted Name in News. May that solar wind be at your back.